Good morning. It's great to see so many familiar faces here today. For those of you who don't know me, I'm Patrick Wyatt. I'm Varjo's Chief Product Officer. So we launched the XR-4 Series now almost 2 years ago. And since then, we've spent countless thousands of hours testing, deploying, demoing it in real-world environments. I think it's fair to say that we've learned a lot in that process, together with you all. And I think it's also sharpened our focus on the use cases that we're trying to solve for. So based on those learnings today, we're announcing 3 things. One is a refreshed XR4, a major software release, and also new commitments on support and service. Together, these things are our combined solution for mission-critical training, and I'm going to show you more about what that is and also a peek into what's coming next after that. So to organize this, because we've got a lot of content to get through, I'm going to sort of talk about 3 main themes here. One's around performance, kind of thinking about, is the headset good enough for the mission? Are the visuals, the tracking, the clarity enough to create high-fidelity simulations? Secondly, deployability. Can we get this out of the lab and into the real world? And thirdly, capability. What are the new features in XR that create new scenarios for training? I have lots of slides to talk about the product content here and have very few quizzes or British jokes along the way. But I was reflecting about the presentation I made for the XR4 launch back 2 years ago. And that was full of, tech stats around resolutions and PPDs, all those kind of things. Today's is quite different. Today's full of real examples of how the features we're building help the use cases that you're building for. So I'm very pleased to talk to you about this some more. Let's start with the most, there we go. Let's start with the most important topic for real-world acceptance of a headset, ergonomics. So fit is a tricky topic because it depends both upon the individuals, about their head shape, etc., but also on the use case. When we first built the XR4, we built it for being able to take on and off really easily in offices or studio environments, and so it was well-balanced, sat lightly on the forehead, and actually it was remarkably comfortable. But I think we've learned there's a few things we want to change now based upon all the rollouts we have with you guys, knowing what to do next. So we have some changes in the next XR4 version. We've made 3 main changes here, principally aimed at making sure the fit is firmer on the XR4 while maintaining its comfort levels. So the first thing we've done is we have added more cushions in the inner side of the headset, so creating the contact points on the cheek. This way there's less risk of lateral movement around when the head moves quickly. Secondly, we've made the headband at the back sit lower on the head. So rather than being straight across, it now hooks down behind your head to create a stronger contact point there. And then finally, we have a chin strap. This is an optional chin strap, which you can add for certain use cases. This was actually a controversial internal decision, but we're not trying to build a consumer headset. We're trying to build a headset which is fit for the mission. And in some missions, this is important. XR4 can now do more things. We've tested this in different environments and situations. We tested it in a helicopter. You've got to look down the floor and see what's going on there. Tested it with extreme air combat maneuvers. We've tested it on full motion platforms as well. We've even tested it lying flat on your stomach at the bottom of a hoist operation test as well. The XR4 can now do all these things thanks to new ergonomics. The other change we've made to ergonomics is the back box, the headset. So what we saw when we went and did some deployments was that with a high back chair, sometimes the back of the headset here can interface with the chair and create some friction for head movements, right? So in this version, we're sending that right down. The back of the headset is much thinner than it was, and the cable reasons improved too, so the cable can go either up or down, depending on what sim you're in. These are, in some sense, very small changes, but I think they also show the level of focus we have on the use case that we're solving for now. We know what we're trying to achieve. Let's talk about the next important performance question, which is the path-through quality. So obviously, for an immersive MR sim, the path-through quality is essential. And that means being able to have both a broad field of view, but also be able to read small details on dials and controls. Pass-through is actually one of the most challenging parts of mixed reality these days, partly because of the big bandwidth requirements to simulate the human eye, but also because the eye itself is very adaptable to different kind of conditions and environments. In the XR4, we made a big step towards that with 51 pixels per degree pass-through and autofocus cameras, but the job wasn't totally done, and we've been working on that ever since. I'll show you some pictures next about how the pass-through has improved since the first launch of the XR4. Those of you who know about trying to put pictures of VR on slides will know it's sometimes hard, so I ask you to look closely at what you're seeing, but the improvements here are real, and they're quite significant. So in order to achieve that high-resolution pass-through in the XR4, we had to make a few trade-offs, and one of those was to, in the focal edition, have a more limited vertical field of view. It's only 80 degrees in the focal edition. And you can see that here with this black area on the cockpit, this notch here. What we noticed, though, in real-life deployments was that it tends to be the case that the virtual content is always at the top and the mixed reality content is always at the bottom. So we thought, what happens if we can move that window of pass-through down a bit? So that's what we've done in the latest XR4 edition. Now we have a full field of view for pass-through because the pass-through now occupies the bottom half of the screen. That allows you to see, better control of your hands, knee boards, cockpit contents, as well as creating a more realistic environment overall for mixed reality. So, bigger field of view. Secondly, the XR4 cameras have physically the highest resolution spot in the middle of the field of view, in the center. What we learned was the most important area for mixed reality is actually the working area where your hands are. That's where it matters to see the mixed reality. So what we've done in this new version is tilt the cameras down by just 10 degrees, and that brings the cockpits and the dials all into the sweet spot of that camera. So what you can see here is on the left, the XR4 as it currently is. On the right, the new XR4. And if you look closely, you'll see the numbers are much sharper on the right? Increased sense of clarity we can get now. Next, let's talk about foveation. So in the XR4, in order to achieve that really high bandwidth, we have to only show the highest resolution area to follow your eyes around. And this is an example here of a before and after we're seeing here. What you see on the left here is what the XR4 looked like at launch, right? So back 2 years ago, where you see a very sharp area right in the middle, in that red box. But actually at the top, some of those numbers are kind of hard to read. And we got a lot of feedback on topic from our customers as well, saying they want to see the whole MFD, the whole screen in the sharp area. So we've made improvements one after another in this respect. And here's where we are now. This is now the size of the sharp area. It covers basically the whole control panel. The top row is now fully legible. We've also made that eye track box move faster, so it follows your eyes about a third faster than it used to. I think taken together, those two things are making that effect of foveation much less visible in Auto 4. And I think when you try the demos we have this afternoon, you'll see that it's actually very hard now to see that effect at all. And that's a really big bit of progress in the path-through. Sometimes colors are really important. This shows you two missile indicators in F-35, where green is full and white is empty. In our previous version of the Varjo base, we noticed, given some feedback, that sometimes these could be confused. In certain lighting conditions, the colors weren't coming through quite correctly. Now, in Varjo base 4.12, the version we released just a few weeks ago, that's fixed. So we have green is green, as it should be across video pass-through. These kind of things are important for mission acceptance. Let's talk now about one of the last thing on performance, which is tracking. So obviously, tracking just got to work. When we first launched the XR4, we launched it with inside-out tracking as a default, and we provided a special variant for those who want to use base stations as well. So we had two versions of the headset. That was fine, but it created some complexity for customers having to pick what they wanted before they could try it, if you like. So in the version we're announcing today, that headset has both Steam VR tracking, base station tracking, and inside out in every model. So no need to choose anymore. You have the best of both worlds. Tracking itself has improved over that period. This is our inside-out tracking, which has evolved over the course of the last year and a half. And I think we're now seeing customers having the confidence to deploy that in their own setups that are more and more challenging. Here we have examples of XR tracking working in dark environments, working inside domes, working even in full motion platforms as well. It's really a very robust and versatile solution. I think we'll see more and more adoptions of that over the coming months and years. So moving on now a bit from performance, let's talk about deployability. The ability to take the headset out into the real world and use it at scale. We've seen over the last 18 months several deployments of the headset of multi-hundred units. And so we've learned a huge amount about that. And I'd like to start talking about a topic which is not particularly sexy, but it's something that's very, very important, which is PC compatibility and headset stability. So the XR4 is a very bandwidth-hungry device, principally because of the mixed reality cameras have this very high resolution pass-through. And what we've seen is that places quite a high burden on the USB connectivity with the PC, and that means the bar is quite high for what PCs work with it. This has been sometimes confusing for customers to know which systems work well and which don't work well with the XR4. So what we're doing now is in every box for the XR4, our secure editions, we are shipping a PCI adapter that you can plug in so you know it will work with the XR4 if your USB onboard ports don't work. Second thing we're doing is that because we test lots of PCs all the time, we know what works well. And so we want to start offering bundles of PC and headsets together. There'll be a bundle offered for laptops and desktops, and one for Europe and one for US. And we'll start doing that from Q4. I think these two things together will mean we offer more security about which systems will and won't work to customers before they start to buy. The next topic, which is very important, is stability. I think we know that the headset needs to start up every time without fail, and needs to stay up for long sessions as well. And we are painfully aware this has not always been the case, and it's been a big focus for us over the last 18 months to improve this. So what we've done is, with all your help, we've managed to isolate the root cause of this issue to the link box between the PC and the headset, and we've fully redesigned that now. So the new link box will ship with every new headset that we're shipping from now on, and we'll also provide that link box for any previous XR4 customer who has any issues as well. This should resolve the great majority of the issues that we've seen here. We ourselves are testing headsets all the time with different systems. We have a bank of PCs and systems in our office in Helsinki. We are testing a couple of dozen PCs now, both our own ones and one provided for us directly by customers with every release of Varjo base. And so I think this gives us more security that we can catch issues before they reach deployments in the field. The last thing to say about this is that we have, I think, in the last 18 months, had quite a rapid pace of improvements in our software. So we've been rolling out improvements to the XR4 software every 2 months. There have been about 12 releases since then. And that's been great for delivering more improvements, but it's been occasionally confusing the customers who want just a stable baseline, if you like, for deployments, to know like the thing they can ship out in the field is just the most solid thing. So we're going to change from next year our deployment strategy ourselves to have a more clear beta program, where there'll be the latest and greatest Varjo-based releases that you can test in the lab and try against and try new things with. And then, opposed to that, we'll have also more stable releases that happen less frequently, but will be only containing mature features that are ready to go into field deployments where they may not be touched for many years afterwards. The other big change I think we've made is that we're now shipping the great majority of our systems not to be used on their own, but to be used as part of much bigger systems. So our mindset itself has moved from shipping like individual boxes to end users to shipping components to system integrators. And that's changed a bit the process we have on our side around support and software as well. So first new feature, the command line interface feature. It's been a recurrent ask from integrators that there'd been a way to use Varjo headsets without having to use Varjo base all the time. The end users need not touch our software, for example. This can be things like eye calibration, or it can be things like headset power status, those kind of features. Sometimes SIs have their own dashboards they want to integrate with. Sometimes they want to have physical buttons even to press to do things. And in Varjo base 4.12, that's all possible. So we now have CLI interface for programmatic interfaces with Varjo base. Users need not see our own software ever, and we're fine with that because in the end we're trying to support the overall SIM experience being strong, not just a headset experience. All right. In order to better support sim developers, we want to move away from this one-size-fits-all of engineering, one-size-fits-all model of engineering as well. So we have on one side a talented team of solution engineers who are on site to help customers. They've got thousands of hours of experience tuning masks and tweaking lighting, those kind of things. And they're available to really improve your setups as required. On the other hand, sometimes there are things which are not in our software right now. There are things which we can't do. And here we're really open to working with you to create new functionality and new features. That could be, for example, a new mixed reality feature. It could be a new helmet mount. These are all examples of things we can do. And many of the features we'll discuss today in this presentation actually start their life as features built for a certain customer to accelerate their development. And we have here in the team today from Varjo, people from our solutions team and our product team who'd like to hear about things that you want to build with us as well. Final thing to say about deployability is really about security. So as a company which is focused on this market, we're making big investments in security, both from a manufacturing point of view and from a software point of view. We have a facility in Helsinki now where we build the majority of our headsets. Most of our business now comes through this factory here in Helsinki, where we have full control of our manufacturing supply chain. On the software side of things, we spend a lot of time working with agencies to get the accreditations required for our software. That means, in this case, one we can talk about is the certificate to field from the US Air Force. It gives us the allowance to deploy our headset into their operational environments. We're also, as a company, making investments of our own into security. We're on the track to having ISO 27001 security, which you know is an information security standard. Let's touch now on our last pillar of this taxonomy, which is the capability we have the headset. I think we want to look at the feature they bring to XR, which will enable new scenarios for simulation. First of these is hand tracking. We launched the XR4 back in the day with hand tracking from Ultraleap, and that's worked great and is still available. But since then, we've worked also on our own algorithms for hand tracking to provide a more simple, out-the-box solution which requires no extra add-ons. So in Varjo 4.12, we've released now out of beta our hand tracking, available to all customers on any license type. And I think a great solution for simple hand tracking requirements for interaction with interfaces or virtual tools. Hand tracking is really all about telling the PC where your hands are, but I think we know that for a convincing experience, you don't want those sort of skeletal VR hands in mixed reality. What you want to see is your real hands. And so we've brought a feature out now in 4.12, which is called hand occlusion. And what it uses is the data just in the pass-through cameras. It's an algorithm that tries to segment out hands from the background environment. So we can overlay real hands in a virtual environment. What this means is that new scenarios are unlocked for mixed reality training. So rather than saying you have a fully real cockpit and a fully virtual outside world, you can mix it up. You can have certain elements virtualized in your cockpit, but still see real hands on top of those at the same time, creating a much more sense of realism there. And it's also demoed outside this afternoon. I think I really recommend you check it out. One great benefit of immersive mixed reality, as opposed to AR, is you have full control over your environment. And that's control not just over the virtual content, but also over the real-world content. And one use case we know is really important is nighttime training. And we want to make that work really well in mixed reality as well. So in Varjo 4.12, we have a new feature called Night Mode. And what it does is it basically adapts the lighting inside the cockpit. Even though the lights in the real world might be on, it modifies the path in real time to simulate a nighttime environment. So you can see here how the cockpit lights are effectively dimmed to make it more consistent with the outside world. There's an excellent demo in the afternoon of this one as well. So that's kind of the full solution we have today across hardware, software, and services for mixed reality training. And I want now to look a bit beyond this to what's coming next. I think nothing here you should take as a promise. These are no commitments about the future. But it's also a great opportunity to have this group here, to get your feedback, to hear about what else you want, and to also, frankly, let you know what's coming so you can build your plans around these things too. So I'll give you a few hints about what's coming in the next year and a bit on our roadmap. One great advantage of our architecture is that we have access to lots of compute power from the PC. So we are able to do things that you couldn't do on headsets that had no wires, for example, right now. And one of these is being able to upscale the video pass-through using cutting-edge AI techniques. So we've been training new models on particular cockpit data in order to be able to upscale the video pass-through. And here you're seeing left to right, the effect of upscaling. The impact is particularly visible on the peripheral area, which is a bit lower resolution in the pass-through. I think we have some work to do still on this. The FPS and the hallucinations are not quite sorted out yet, but I'm pretty confident this will be a big jump in capability for the XR4 when it comes out, and is a good example of a thing we can deploy without having to create new hardware variants. We can add this as a software upgrade to our current products. A similar example is around using AI for object masking and tracking. So here, again, we're using the cameras to track an object without a need for pucks or markers or chroma, all these kind of things. This, I think, creates new deployment scenarios and new ways to follow objects around. You can imagine it's being used for masking a cockpit automatically, or for tracking weapons, or segmenting out your co-pilot so you can see them in real time as well. Another area which we think has long been underexploited is the use of the data we collect about the pilot's experience in the sim. So we have quite rich data around eye tracking, for example, and this is used to both track what virtual objects the person is seeing, but also can be used to create aggregate metrics around things like cognitive load, for example. We had a presentation this afternoon from Irish Defence Forces and our partner VRE on just this topic. If we look further forward, we actually want to make this data even richer. So we know kind of uniquely where the pilot's looking at any one time. We know where the head is, we know where the eyes are. And so if we combine that with a labeling of the data areas inside the cockpit, like knowing where the displays are, where the throttles are, we can create new semantic scenarios for mission debrief. We can say what was being looked at, what screen was someone looking at when this happened, for example. I think that can both create higher quality feedback for pilots, but also might even improve the productivity of trainers in some scenarios.